Hello, this is Damien Vero. This is my small to medium business server hardware options presentation for Workstation and server. Firstly, we need to look at buying versus pre-built. The overview of products. Some things we need to consider is the form factors, central processing units, ECC memory, redundant power supplies, motherboard, and storage solutions. Firstly, we'll look at form factor. With form factor, the server starts with determining space availability and determining what type of chassis is best suited for the available space. If space is limited, either a small rack mount unit or a mini ITX chassis should be selected. Otherwise, you should go with a larger form factor, including normal rack mounted chassis or a full tower chassis application. Larger form factors not only open up the available options for motherboard and CPUs, but it allows for better cooling solutions to be employed. If space is limited, I would recommend a larger form factor chassis. If space is available, I'd recommend a larger form factor chassis, not only for the previous mentioned reasons, but also the fact that a small form factor system can fit in a large form factor chassis, whereas a small form factor chassis cannot accommodate a larger form factor motherboard. Physical space is very limited. I would turn to cloud applications for business servers needs. The downside to cloud servers is price dramatically increases as data storage grows and the head count of people utilizing the server increases. Next, we need to look at CPUs. The use of the server is imperative to determine how many logical physical cores are best for the application. Business time is money, and many workflow applications such as database queries, video rendering, CAD programs, and many more applications that gain a significant performance increase by spreading the workload across many cores. Generally, the higher the core count, the lower the single thread performance. So chips that offer a higher core count are typically much more expensive, often 5 to 10 times the amount of a typical consumer chip. However, they generally pay for themselves in a time-saved process. Additionally, heat dispersion is a factor. The higher the clock speed, the more cores packed into a chip, the hotter they tend to get. So you'll need to look into efficient cooling solutions such as AIOs or custom liquid cooling loops. Although custom liquid cooling loops require a lot of maintenance and generally they're extremely expensive. I would generally recommend an AIO or efficient air-cooled offerings. If the application requires a great deal of cores, there's the option to explore motherboards that allow for multiple CPUs to work in tandem. You'll need to look for your QPI links or your hypertransport support. Next, we need to look at ECC memory. Typically, servers run 24/7, so it becomes mission critical to run a stable system. General memory faults or errors quickly crash the system or make it act erratic or unstable in return, creating potential downtimes. A very simple definition of ECC memory is they detect and correct single-bit errors, preserve the integrity of the data, prevent data corruption, and prevent system crashes and failures. Next, we need to look at redundant power supplies. Redundant power supplies have multiple power supplies into one unit. If one goes down, the other one picks up, and it's a seamless process so that the system is stable and does not crash. This is imperative for a server in keeping it stable and up and running. Next, we need to look at the motherboard. There's many factors here to consider. Firstly, you want to make sure that you got the proper form factor. Secondly, you want to make sure it has the correct socket or sockets and supports the desired CPUs. Third, make sure it supports ECC memory and the desired capacity. Make sure it has the desired expansion slots and interfaces needed for the application. Next, we're going to look at storage solutions. Although prices on solid-state drives has dropped significantly in the last few years, they're still relatively expensive. In general, I would recommend installing the operating system for both consumer and server applications on a solid-state drive for both performance and reliability. If the application requires the use of solid-state drives due to bottlenecks and requirement of low latency interactions, I would suggest the use of enterprise solid-state drives. Unlike consumer solid-state drives, enterprise SSDs peak the performance for the first few seconds of access, but also use a large over-provisioned area for high sustained steady-state performance over a long period of times. Storage solutions can be very expensive, especially when dealing with business applications. Generally, a mirrored RAID solution is advised, i.e. RAID 5 or RAID 10 cloud storage, which is also expensive, or NAS solutions. SSDs are much more stable since they don't have mechanical moving parts like a platter drive, so they're more reliable. So it is definitely an option, but it's an expensive option. In summation, as you can see, there are many factors to consider when choosing components to build a server, and I barely skimmed the surface of the depth and complexity of choosing the right components for custom solutions, but these are a few things that you might want to look into. Next we need to look at is business and management. Selecting the correct hardware for the job is a daunting but necessary task. When it comes to business management for small to medium businesses, there's one factor that should be weighed heavily. Does spending more money up front equate to save time and increased return on investment? First thing you need to look at, what is the task of the server? A few things we'll look at. Providing authentication for the domain. For this application, you generally any 64-bit CPU and 4+ gigs of RAM will suffice. For hosting a website, both the front end and back end need to work in tandem together. So here you're going to want hardware redundancy and increasing overall RAM capacity. If you're doing controlling shared peripherals, this is a low-powered application, and generally a recycled older personal computer will suffice. If you're looking at file servers, you typically need a large capacity storage. NAS solutions or multiple hot swap drive bays and various RAID options benefit this application. If you're looking at database services, solid-state drives greatly improve the performance of this application. However, it's very expensive. Mail servers are pretty much the same as in terms of hardware as file servers. Application servers benefit greatly from enterprise-level storage solutions and ECC memory. Next, licensing and pricing. Pricing for building a server varies so greatly, ranging from a couple of dollars to thousands upon thousands of dollars, so that's beyond the scope of this paper. I will, however, look at a couple options with operating system pricing. As you can see here, for Windows Server 2016, if you want a data center license, you get 16-core license. It requires Windows Server Cal, and it's $6,152. A standard license gives you 16-core license, requires Windows Server Cal, and it's $882. And Essentials, which would be applicable for most small businesses, would be 25 to 50 devices, no Cal, and $501. Mac has an option, but you have to run Mac OS. Linux has a variety of options. Ubuntu is usually the way to go there. And Solaris I can find a lot on, even though it's semi-popular. Oracle solution. There is cloud server pricing. Here are two options. IBM Cloud Dedicated Servers has a wide range of options per need of the customer, and the same with Microsoft Azure. Operating system requirements are relatively low. You can see like 2008 only requires 1 gigahertz, whereas 2016's 1.4 gigahertz. RAM is generally anywhere from 5 to 2 gigabytes, and storage is anywhere from 10 to 32. Competition in the future. Here we would look at server applications for small to medium businesses leaning towards cloud services and applications due to a variety of reasons. Firstly, the initial investment for cloud-based server applications. There generally is no upfront fees with the more pay-as-you-go retail design, whereas purchasing and selling the server can have a significant price tag up front. Secondly, ROI. Server hardware generally does not hold its original retail value for very long. Thirdly, the need for an in-house IT support is virtually eliminated, or at the very least reduced. Fourth, the budget for security solutions and employed cloud-based solutions with virtualizations is dramatically decreased. Fifthly, the amount of physical space required is much smaller. Last but not least is overall pricing. More than not, it's significantly cheaper to utilize a cloud-based solution when compared to the upfront costs, maintenance, physical space requirements, and more factors that a physical in-house service require. Additionally, you need to look at the seamless and cost-efficient way in which a business can simply expand their cloud-based server capacity. They simply just order the services they want and get up and running. Final recommendation. At this time, I'd be leaning towards cloud-based servers or pre-built. I would not recommend a custom-built solution unless the application absolutely requires it. A viable solution may have an in-house server that is designated to host a website and outsource an email server to a cloud-based solution. Pretty much the options are limitless. Prior to doing the research for this paper, I was very pro-build. However, after doing the research for this, I'd be more leaning towards cloud-based or pre-built options. Thank you, and have a great day.